So now that we've got a concept for what the maps are, let's talk about using them. So the map within a software application is going to be used in very similar ways as we mentioned the concept of a database. If you've taken a database class, it's going to be a way to quickly look up some data. It's going to be a way to refer to data in some sort of quick lookup, but all within the job application, without having to go connect to other sources and be able to search stuff. It's not quite as powerful in that I can't search and filter and everything the same way, but it's local, it's quick. And so the map organizes our data and allows us to search on it very quickly without having to do looping or additional code. That's built into the map class, and it's built into the way we compare it using either the comparator for the tree map or the hash code for the hash map. And so in order to use that, we can basically take advantage of it based off of some designs. So let's take an example. We have a player object and a team object. And so we're going to organize the data in many interesting ways. We want to basically keep track of the data, say, so which player is number 23? So we have all the players inside of there. I want to look them up by number because I maybe want to do that in, I have some requirement to look that up in my code. So I can go ask that question. Or I can ask a question like, which team does a player play for? Or which players are on a team? So we can use maps to arrange data like this in a static way inside of my Java application without having to rearrange it and search dynamically all the time. So, for instance, I might have a number in which I want to look up a object value, and it's great when I'm using primitives, either capital I integer or strings or things like that, because they have most of the work built in. They already are comparable. They already have hash code implemented, so I can use either type of map and not have to do any additional work. So again, we want to say, okay, what player was number 34? Well, that was the great Walter Payton, and so on and so forth. You can see all these different values inside of there. But if I have a key, I look it up inside of the map. At this point, I don't care if it's hash map or if it's a tree map. I'm just conceptually looking at the map. I don't care how it's stored internally. It's shells, key value pairs inside of there that I'm caring about. So I can do the same thing between objects. I can say, excuse me, what team does a player play for? My key now is a player object. At this point, I have to either realize a comparator to be a tree or a hash code to be a hash map. I have to do that. But the same thing is true. I can have any object I want to as the key, any object I want to as the value. So a player can play for one team at a time, so this logically works well. If I say, what team did Peyton Manning play for? Well, at the time, it was Indianapolis. Now, it's not Indianapolis anymore. It's playing for somebody else. I would replace that in over there for Peyton Manning. It would get replaced to Denver now. It would be, placed over this later on in time. And so the object would just change. That would be fine. Peyton Manning would still be there. The value would just be changed. The other way around, though, if I want to ask the question, which players play on a team, I would have to construct the map differently. So I can put the team out there as the key, again, assuming I've done either my comparator or my hash code appropriately. And then I can have some sort of complicated object to list the players. It could be an array. It could be a collection. It could be a map. So I can have a map that points to a collection of values. I can have a map that points to a map of values. I can have a collection that stores maps inside of there. I can have a map of collections of maps. I can store any of these there because they're all of type object. That's what gets stored in there eventually. And the implementation of these guys is all based off of that abstract data. Anything can be stored as a target. So I can go through, and when I go back and say, who are the players on Chicago, I don't get a single player object back. I get back that list. I get back that array that has all the players in it, and then I treat it as such. I can go loop through that list. I can go iterate through that array, whatever I want to do inside of there. Now, to be fair, it's a very powerful technique, but don't overuse it. In many cases, the easiest thing to do is in the player, I have a reference to a team, and I point to that team as a local variable inside of that. Or as a team, I have a list of players, and I point to that inside the team. The reason to doing the lookups is not basically to store data like that. That's not the whole point of maps. The whole point of maps is if I have a dynamic relationship that not the player plays on the team right now at this time, what season they're playing for now, but I have some sort of dynamic relationship. Well, let's say a fantasy football team. I could do that in a way that doesn't mess with the core data. I can just move it around in some sort of interesting way and be able to represent it outside of the core model that I'm doing inside of there. So the point being here is I'm showing you some fanciful stuff, but don't get the idea that's the way you're supposed to design. It's just a way of representing data that's essentially temporary. Not the way you want it for all time, just the way you want it for a little bit, for whatever you're doing right now. So beyond that, we need to start looking a little bit at how do we code maps. And we're going to do that next. We're not going to get into detailed demonstration too much because you're not going to be asked to do that. But I do want to show you a little bit about what is involved with the code of maps, just so you've seen it and you can play with it some more on your own. So we're going to do that next.